Some students will say that the progress bar can already show the power, and the next step is of course shooting. When the touch is released, the basketball is thrown out. But have you ever thought about it? When the basketball is moving in the air, it is not reasonable to throw it out. So, we should first consider the state of the basketball. Let's think about it. How many states should a basketball have? Idle is a state. When the basketball is in the idle state, full screen touch can enter the charging state. Only then can the progress bar become longer. So charging is also a state of the basketball, which is equivalent to the process of preparing to shoot. When the touch is released, the basketball is thrown out and enters the throwing state. So, the basketball should have at least 3 states. We can use an enumeration class to represent the state of the basketball. Create a new TypeScript file in the scripts folder, and name it basketball state. Double-click the script file to edit it. We will change it to an enumeration class and add 3 states, idle, hold, and throw. Representing the idle, power added, and throwing states respectively. Create a new TypeScript file in the scripts folder, and name it basketball controller. It is used to control the movement of the basketball. Drag this script to the basketball node. Next, we need to think about how to control and switch the basketball state. You see, when the game starts, the basketball is in an idle state. At this time, the basketball should be stationary, that is, the gravity should be temporarily disabled at this time, and the basketball should be placed at the shooting position, that is, the initial free throw line. Therefore, we declare a member variable state in basketball controller to record the state of the basketball. Then make corresponding processing according to the state of the basketball in the onUpdate method. If the basketball is in an idle state, the initialization operation before shooting should be performed. Let's write a method ready to hold and call it in the corresponding branch. In this method, we need to disable the gravity on the rigid body component. Therefore, you need to declare a member variable body first. Then disable the gravity of the rigid body in this method. Here everyone should pay special attention to one point. If you want to get the member variable of the component on the node, do not initialize it when the variable is declared, otherwise it will cause the component to not be obtained. In addition, it should be noted that simply canceling gravity is not enough because the component already has an initial velocity when it is first loaded. If the velocity of the rigid body is not set to zero, the rigid body will fall slowly under the action of the initial velocity. Run, and when you start the game, the basketball will be stationary in the air. At this time, we can adjust the position and angle of the camera in real time in the running state. Make it look like the first-person perspective of a basketball player. After adjustment, on the right side of the camera node, click and select Copy Component to copy the transform attribute value of the camera node. Then exit the running state. Then set the value just copied to the camera node, and select Paste Component Values. Okay, the posture is adjusted. The next step is of course to shoot. Just now, everyone has seen that in 3D games, the velocity of the rigid body is a three-dimensional vector. So, shooting is nothing more than giving the rigid body a velocity, that is, setting a three-dimensional vector value. The key is how to set this three-dimensional vector reasonably. If you set it aimlessly, the probability of shooting into the basket is very small, which will inevitably bring frustration to players and lead to user loss. We switch to the 2D perspective and look from top to bottom. We find that at the beginning, the basketball and the basket are both located in the z-axis direction. Therefore, when shooting, set the x component of the rigid body velocity to 0 and give the rigid body component a suitable velocity component in the y and z directions. Switch to the left view. We use a 45-degree elevation angle to shoot. Drag game to the right side of the scene window, and display them side by side for easy observation during runtime. Return to the code editor. Set a shooting speed. Write a shooting method, and call the corresponding branch of the onUpdate method. Turn on gravity in the shooting method. Calculate the component velocity in the z-axis direction. Calculate the component velocity in the y-axis direction. Set the shooting speed. Call the corresponding method of the rigid body. You can check the engine API for the rigid body method. Similarly, you can also check the API for the way the force works. We will not explain too much here. Students who are good at learning should master the skills of consulting APIs. Run. Everyone found that the basketball flew out in a straight line. This is inconsistent with our expectations. Let's see where the problem lies. First, we analyze the code. It is found that the throw method is called in the onUpdate method. After the call, the state of the basketball has not changed. When the next frame comes, the basketball is still in this state, so the throw method will still be called. Therefore, a force will be applied to each frame, causing the basketball to fly out in a straight line. How to solve this problem? First, we add a basketball state flying in the basketball state enumeration class. Indicates that the basketball is in a flying state. Then add the corresponding processing branch to the onUpdate method in the basketball control script. At the end of the throw method, change the basketball state to flying. Run and test. It is found that the trajectory of the basketball is finally a parabola. Here, in order to facilitate the adjustment of the shooting speed at runtime, let's make some changes to the code. Adjust the shooting speed. Run. Found two problems. The first problem is that it feels a bit difficult to score a goal when shooting at a 45-degree angle. We change the shooting angle to a 60-degree upward angle. Similarly, we can set a parameter so that we can modify it in the editor when testing. Run and test. This method makes it easy for us to find the appropriate numerical parameters by modifying the parameters during the development process. However, there is another problem. The basketball will pass through the backboard, and it will not collide with the basketball stand. The reason is that we did not add a collision body to the basketball stand before. Next, we will add a collision body to the basketball stand prefab. Drag the previously made basketball stand prefab to the left hierarchy window to get a new node. Right-click this node, select Prefab, Unpack, and unpack the prefab. Select this node and press F. While holding down the Ctrl key, click the base, backboard, and the top beam of the basketball stand. In the inspector window on the right, click Add Component, search for Box, and add Box Collider to these three parts. While holding down the Ctrl key, click the two pillars of the basketball stand. In the inspector window on the right, click Add Component, search for Collider, and add Capsule Collider to these two parts. Select the basketball stand to which some collision bodies have just been added. Click the eye icon in the upper left corner of the scene window and check Display Gizmos, or press the shortcut key Alt+B. You can see that the part with the collision body added will be wrapped by a green geometry. At this time, the basket and the net do not have collision bodies. Let's add a collision body to the basket first. All nodes that are not unlocked need to be unlocked before editing. Select the steel components of the basket and add mesh collider components to them. Note that components that are not made of the basket do not need to be added. Similarly, unlock the net node. Find the real net part and add the mesh collider component to it. Save. Delete the original basketball stand prefab. Then drag the basketball stand node to which the collision body has just been added to the prefabs folder in the project window. Generate a new prefab. Then unlock the node just now. Select the two previous basketball stands in the hierarchy window and delete or hide them. Drag the prefab to the left hierarchy window to generate another basketball stand. Modify the coordinates of the two basketball stands. Set the Z value of 1 to -10. Set the Z value of the other to 10. One needs to be rotated 180 degrees around the y-axis. Ctrl+S to save. Run and test. Adjust the relevant parameters in the script mounted on the basketball node, that is, adjust the shooting speed and shooting angle. Test again. It is found that the collision between the basketball and the net is also like hitting a wire mesh. How to solve this problem? Let's think about it. Recall what we talked about earlier and see if we can find a solution.